Hello and good morning, everybody. Welcome back to my classroom. Today I'm going to continue with you the midterm review, and I'm going with the chapter of real numbers. So we defined that the rational number, remember, that is any number that can be written as a fraction, a over b. And we knew that all rational numbers can be a repeating decimal or a terminating decimal. If it's not one of these, then it is irrational number. An example of repeating decimal is 0.45 with a bar here. What does this bar mean? Means that my number is 0.454545 forever. And this is equal to the fraction 5 over 11. Look, 5 over 11, it looks like a over b, so this number is a rational number. Terminating decimal means I have a limited number after the decimal point. 1 over 8 is 0.125, which is a terminating decimal. So this number could be written as 1 over 8, which is a over b. Then this number is a rational number. Now, how can we express a fraction as a decimal number? We do the long division. I have here an example of 5 over 11. 5 from here, 11 from there. We start dividing. 5 divided by 11 gives us 0. We put the decimal point here, 50 divided by 11, it's 4. Okay, 4 times 11, then it's 44. 50 minus 44 is 6. I take the second 0 here. 60 divided by 11 is 5. 5 times 11 is 55. 60 minus 55 is 5. I push the next 0. 50 divided by 11, that is 4, and so on. So it keeps repeating 4, 5, 4, 5 forever. So at some step here, I'm stopping, and I would say 5 over 11 equals to 0.4545, etc., which is equal to 0.45 bar, since 4, 5 are the repeating numbers. Another example is 3 over 5. I divide 3 by 4. So 3 divided by 4 is 0. Put the decimal point here. Add another 0. 30 divided by 4, it's 7. 7 times 4 is 28. 30 minus 28 is 2. I push the 0. 20 divided by 4, it's 5. 5 times 4 is 20. 20 minus 20 is 0. I'm finished here. So this is a terminating decimal. I don't have any remainder here. So 3 over 4 is 0.75. Look, both numbers are rational. This one is repeating and this one is terminating. Why they are rational? Because they can be written as a over b. A over b. Alright, now let's solve a few questions regarding the square root and the cube root. Okay, I have this equation here, x cubed equals to 729. I want to solve this equation for x. What I'm going to do is to take the cube root for both sides. So x cubed with cube root and 729 with cube root. Okay, we said that the cube and the cube root cancel out. So this gives me x, and this is the cube root of 729. So from your list of perfect cubes, you know that the cube root of 729 is 9. So my x equals to 9. This is the value of x. Another example, x cubed equals to 8 divided by 125. Again, I'm going to apply the cube root for both sides of my equation. Cube root of x cubed equals to the cube root of 8 divided by 125. Now, the cube root cancels with the cube, so this is x equal to the cube root of 8 divided by 125. So what is the cube root of 8? It is 2. What is the cube root of 125? It is 5. So my x equals to 2 divided by 5. So the solution is 2 divided by 5. All right, next equation, x squared equals to 196. Okay, from your list of perfect squares, you know that 14 squared is 196. So my x is 14. Now remember, we said that the square root gives you all the time two values, opposite values, one with plus, the other one with minus. So you can write plus 14 and minus 14, or you say plus minus 14, two values. The plus 14 is the main or the principal root, so we usually use it, but in general, try to use both of them, plus minus 14. X cubed equals 512. From your list, you can take the cube root of both sides, so your x equals to 8. Okay, why x equals to 8? Because 8 cubed is 512, or 8 times 8 times 8. 3 times gives you 512. Another one, x squared equals to 9 divided by 256. What is my x here? Take the square root of both sides. So square root of 9 is 3. Square root of 256 is 16. Since this is square root, we have two values, plus minus 3 over 16. Finally, x cubed equals to 64 divided by 343. How can I solve this equation? Again, taking the cube root of both sides. Cube root from here cancels out with the cube. So my x equals to the cube root of 64 divided by 343. The cube root of 64 is 4, and the cube root of 343 is 7. So my solution for this equation is x equal to 4 over 7. Let's solve other equations. X squared equals to 324. Remember all the time to use the list of perfect cubes and perfect squares because they are the most used list in this case, especially the 15 to 21st values. So x squared, I will take the square root from this side, square root from the other side. Square root cancels out with the square, so my x is square equal to the square root of 324. In this case, my square root is 18 or minus 18, right? Both of them. You can write also plus minus 18 as we do here. X squared equals to 25 divided by 144. Okay, take the square root of both sides. X equals to square root of 25 is 5. Square root of 144 is 12. Now this is the principal root. We have the other root, which is negative, minus 5 over 12. Now, x cubed equals to 343. Okay, from the list, you know that the cube root of x equals to the cube root of 343, which is 7. I included in the last slide here the list of perfect squares and perfect cubes you may use all the time. Here is limited to 15, but I advise you to write also down the values of 16, 17, 18 until 20. All right. Now, let's go to other questions. Which number is not the square of a whole number? What do you think? 100 is the square of 10. 400 is the square of 20. So they are squares of whole numbers. Whereas 800 is not. It's not a square of a whole number. What does it mean? It means the square of 800 is a number that contains a decimal. In fact, the square of the number 800 is 28.28427125 and so on. So it's not a whole number, not the square, so the answer is C. Question 4. How many square roots does the number 20 have? What do you think? It is C. In fact, all the numbers have only two square roots. One is positive, the other one is negative. There is no zero square roots and there is no one only square root. So every number has two square roots, remember, plus and minus. So this is not only for 20 but for any number. Question 6. Between which two whole numbers is there square root of 18? We know that the square root of 18 is not a whole number. Why? Because 18 is not a perfect square. So between which two values the square root of 18 is? Now, what is 4 squared? It is 16. 5 squared is 25. So 16 and 25. 18 is between 16 and 25. So the square root of 18 is between 4 and 5. So the answer is A. B is not right because the square of 6 is 36. Square of 5 is 25. 18 is not between 25 and 36. The same thing for C, which is much bigger. So the right answer is A. This is how to predict actually the square root of non-perfect square. So you try to find the two perfect squares that is in between, take their square root. So your square root will be between these two values. Now, which of these integers is not a whole number? Easy. The answer is A. Why? The whole number are always positive. 6 is positive, 66 is positive, but minus 6, it contains minus, then it is an integer. Look at this diagram here. So all the numbers that have minus, they are integers, they are not wholes. So any number that doesn't contain a minus or it has plus, it's a whole number. But the minus numbers are integers. Question 10. Which statement is false? Some integers are irrational, some integers are whole numbers, some rational numbers are integers, some real numbers are irrational. All the time, remember this diagram. Okay, here it says, let's check the others and go back to A. B. Some integers are whole numbers. So whole numbers are inside the group of integers. So for example, 1 is a whole number and it is an integer. So some integers, in fact, they are whole numbers. These ones are integers and whole numbers. So B is correct. What about C? Some rational numbers are integers. The same thing. So this is the group of rational numbers. Okay. And we have here integers. So these integers are rational numbers. So sometimes, or your rational numbers are integers sometimes. D. Some real numbers are irrational. Some real numbers are irrational. So this big group is all under the rational numbers. The statement here says some real numbers are irrational. Yes, we have few numbers here that are real numbers and they are irrational. So this statement is true. Since the question is asking for the full statement, then this is A. Why? Because it says some integers are irrational. Look, this is the group of irrational numbers and these are the group of integers. They don't intersect. So there is no integer that is irrational. Never. So this statement is false. 12. Is 11 over 128 equal to a terminating decimal or repeating decimal? How can you answer this question? You do the long division. I did it here. 11 divided by 128, it's 0.0859375. It stops here. And remainder here is 0, 0. So this fraction here is a terminating decimal. All right, let's continue. Express the fraction 11 over 30 in decimal form. So what we do here, we just make the long division as I explained before. Here I'm just writing the final answer. 11 divided by 30 gives you 0.3666, etc. So 6 is repeating digit here, so I will put a bar on the top of 6. So 0.36. Find the two square roots of 9 over 4. We take the square root of 9 over 4. So I have two square roots, be careful. That is plus 3 over 2 and minus 3 over 2. Okay. 16. Write the next four digits in the repeating decimal of 4.715 bar. That's so easy. Since I have a bar above 15, this means that the number 15 is repeated. And the question asks for the four next digit after the 15, so it will be 1515. 1515. Clear? Let's move to the last question. Write all names that apply to each number. Then place the numbers in the correct location in the Venn diagram. This diagram is called Venn, by the way. You remember we did an example like this in the class. We gave it as homework as well. So let's do it quickly. What is the minus square root of 9? First, I need to simplify it. Minus square root of 9 equals to minus 3. 9 is a perfect square, and its square root is 3 plus 3 or minus 3. In this case, we take the principal one, that is 3, multiplied by minus here, don't forget, so this is minus 3. So this is what? Minus 3, it is an integer. So the minus square root of 9 is an integer. Now, since it is an integer, it is also a rational and it is a real. Don't forget that. Any number that is here, it's included in this group and it is included in this group. So integer, rational, real. Now what do you notice here, guys? There is a mistake actually. This should be minus square root of 9, not square root of 9, and it should be written in the integer. I'll correct it in the PDF later. Square root of 50 is what? Is 50 a perfect square? No, I don't remember. I can see it in the list here. I don't have it. I have 49 and 64. I don't have 50 in between. So 50 is not a perfect square. So it should be irrational. Remember this rule all the time. If your number is a perfect square or perfect cube, okay, then its square root for the perfect square and the cube root for the perfect cube is rational. But otherwise, if it's not perfect, then directly put it here. Directly put it in the irrational numbers. Like as we said, square root of 2, square root of 3, square root of 5, square root of 7. All of these are not perfect squares, so just put them in the irrational numbers. Again, square root of 50 is irrational. Do not forget that irrational is under the real numbers, so it's irrational and real. 16.6, okay, it's very easy. It's terminating decimal, so it is rational and real number. If I have a bar here on the top of 6, what do you think? Again, it is rational because it's a repeating decimal, and we can write it as a over b. So it is rational and real number. 257. What is it? Okay, clear. It is a whole number. It is an integer and rational and real. Every whole number is an integer and rational and real number. Now 8 plus 1 over 2, what is it? It is a rational number. Why? Because I can write it as A fraction. This one is equal to 8 plus 1 over 2, which is 8.5 if you want to. 8.5 is a terminating decimal, so it is a rational number and real number. Rational and real. Finally, square root of 16. What is it? Very easy. 16 is a perfect square and its square root is 4. Okay, so it is a whole number. Square root of 16 is a whole number. So it is also an integer, rational and real. Alright? So remember, when you are describing these, you should write all what applies. That's what this question says. All names that apply to each number. Okay? Finally, this is a perfect cheat sheet that you can use. Okay? Do not forget to join to my classroom at classroom.google.com. For those who did not join yet, go there, sign in from your Google account, and put this class code to join it. Feel free to send your questions, your concerns, your comments. I will be answering you from there. Alright, have a nice day. See you in the next session.